The solar system is a realm of marvels and mysteries. For centuries, it has tantalized humanity with secrets hidden in its depths. From the volcanic plains of Venus to the icy cliffs of Pluto, each discovery has reshaped our understanding of the cosmos. Yet, perhaps the greatest mystery of all lies not within the planets we know, but in the shadows of the outer solar system, a place where gravity hints at something massive and unseen. Beyond Neptune's orbit stretches the Kuiper Belt, a vast, frozen expanse encircling the solar system like a ghostly halo. Discovered in 1992, this enigmatic region is home to countless icy bodies, primordial remnants from the formation of the solar system. These objects, known as Kuiper Belt objects, KBOs, range from small chunks of ice to dwarf planets like Pluto and Eris. The Kuiper Belt spans from 30 to over 55 astronomical units from the Sun, a distance so great that sunlight takes hours to reach its outermost edges. The Kuiper Belt is more than a collection of icy debris. It is a cosmic graveyard, a repository of secrets that holds the key to understanding the solar system's distant past. Formed from the leftover material of the solar nebula, it is a place where time seems to stand still. But amidst the quiet stillness, strange patterns begin to emerge. Objects like Sedna, drifting on elongated orbits, defy expectations. These trans-Neptunian objects don't move randomly. Their paths suggest the presence of a massive, hidden force, a force that science cannot yet explain. Unlike the 8 known planets, which follow predictable orbits along the ecliptic plane, these distant objects cluster and tilt in ways that challenge the very foundations of planetary science. Could these anomalies be the fingerprints of a hidden giant? Welcome to the mysteries of the unknown, and this is the story of Planet 9. To unravel this mystery, we must look back nearly 2 centuries. In 1846, astronomers faced a similar challenge. The orbit of Uranus wobbled, deviating from predictions. But this was no random anomaly. It was the gravitational pull of an unseen planet, Neptune. By following the trail of gravity, scientists revealed a world no one had ever seen, proving that even the invisible could be found. Today, nearly 200 years later, we face another enigma. This time, the puzzle lies far beyond Neptune, in the frozen outskirts of the solar system. Here, in the Kuiper Belt, astronomers have uncovered strange clues, the inexplicable clustering of distant icy objects. Once again, gravity points to something massive and unseen, a hypothetical Planet 9. Planet 9, if it exists, would be unlike anything we've encountered. Astronomers estimate it could be up to 10 times the mass of Earth, a super-Earth, exiled to the solar system's farthest reaches. Its orbit is so vast and elliptical that it may take tens of thousands of years to complete one revolution around the Sun. Some believe it was cast out during the solar system's chaotic youth, while others suggest it could be a rogue planet, captured from another star. But how could such a giant planet evade detection for so long? What secrets might it reveal about the solar system's turbulent history? And what would it mean for our understanding of the cosmos if we finally found it? For generations, we grew up learning about the 9 planets of the solar system. At the edge of this planetary family was Pluto, a tiny, icy world discovered in 1930 and celebrated as the 9th planet. But in 2006, everything changed. Pluto was reclassified as a dwarf planet, its planetary status stripped by a decision that sparked controversy and debate around the world. The International Astronomical Union made the call, defining a planet as a body that orbits the Sun, is spherical in shape, and has cleared its orbit of debris. Pluto failed the 3rd criterion, as its orbit overlapped with that of other Kuiper Belt objects. Among the astronomers who supported this decision was Mike Brown. whose discoveries of other large Kuiper Belt objects like Eris, a world even more massive than Pluto, challenged our traditional view of the solar system. Pluto is fascinating, but it's just one of many similar objects, Brown said. Its demotion wasn't about diminishing its importance, but about refining how we understand the solar system. Yet while Pluto's reclassification reshaped our view of the solar system, it also set the stage for an even bigger mystery, the hunt for a truly massive ninth planet. The first hints of Planet Nine's existence began to emerge in the early 2000s. In 2003, astronomers discovered Sedna, a distant object with a highly elliptical orbit that couldn't be explained by the gravitational influence of the known planets. Its discovery raised questions. Was Sedna's orbit shaped by an unseen giant lurking in the outer reaches of the solar system? Over the following decade, more peculiar Trans-Neptunian Objects, TNOs, were discovered. Their orbits displayed a strange clustering, aligning in ways that defied the expectations of random distribution. By 2014, scientists like Chad Trujillo and Scott Shepard proposed that the gravitational pull of an unknown planet might be responsible. In 2016, the puzzle reached a turning point. At the California Institute of Technology, Konstantin Batygin and Mike Brown conducted detailed simulations to test these anomalies. Their results were astonishing. The alignments of the TNOs couldn't be explained by chance or observational bias. Instead, the data pointed to the gravitational influence of a massive, unseen planet. We calculated the odds of these orbital alignments happening by chance to be less than 1 in 500, Batygin said. Something massive is out there, and it's shaping the orbits of these distant objects. These strange alignments are like cosmic breadcrumbs, leading scientists toward an elusive truth. The orbits of these trans-Neptunian objects cluster together in unexpected ways, tilting and aligning as though guided by an invisible shepherd. As Mike Brown put it, it's like seeing the ripples on a pond without knowing what caused them. For decades, astronomers dismissed these patterns as coincidence or observational bias, but as more TNOs were discovered, each exhibiting the same peculiar alignments, it became clear that something extraordinary was at play. If Planet 9 exists, it would be a world unlike any other in our solar system. And astronomers estimate its mass to be 5 to 10 times that of Earth, making it a super-Earth, a type of planet common in other star systems but absent in our own. Its orbit is extreme, stretching between 400 and 800 astronomical units from the Sun, with an elongated and tilted trajectory that takes 10 to 15,000 years to complete a single revolution. Such an orbit is consistent with theories suggesting Planet 9 was flung to the edges of the solar system during a chaotic episode in its infancy, possibly ejected by gravitational interactions with Jupiter or Saturn. Alternatively, Planet 9 could be a rogue planet, a wanderer that was captured by the Sun's gravity billions of years ago. Its origins remain a tantalizing question, with possibilities ranging from a primordial member of our system to an interstellar interloper. Imagine a world where temperatures plunge to minus 220 degrees Celsius, where sunlight is so faint it barely illuminates the icy terrain. Its surface, if solid, could be composed of frozen gases and ices, surrounded by moons that drift silently through the void. This is Planet 9, a planet shrouded in perpetual twilight orbiting in the cosmic wilderness. The influence of Planet 9 extends far beyond its own orbit. Its gravitational pull shapes the orbits of distant Kuiper Belt objects, clustering them in peculiar alignments. Simulations suggest that it could even explain the high inclination orbits of some objects, tilted at extreme angles to the ecliptic plane. Moreover, Planet 9's presence might account for the unexplained tilt of the Sun's rotational axis relative to the plane of the planets. Its distant mass exerts a subtle, cumulative tug on the inner solar system, creating a slight but measurable shift over billions of years. Even comets and small bodies in the Oort cloud could be influenced by Planet 9's gravity, redirecting some into the inner solar system and contributing to the dynamic processes that shape our celestial neighborhood. Could Planet 9 have formed in this frigid cold and darkness, or was it cast out during the violent birth of the solar system? Could it hold clues about other planetary systems and the forces that govern their evolution? The search for Planet 9 is driven by gravitational anomalies that defy explanation. But could there be an alternative cause? Over the years, astronomers have proposed several possibilities to account for the strange behavior of trans-Neptunian objects. One hypothesis suggests that the clustering of orbits in the Kuiper Belt isn't caused by a single massive planet, but by a swarm of smaller objects. These objects, collectively exerting a gravitational influence, could theoretically produce the observed pattern. However, this idea quickly falls apart under scrutiny. For such a swarm to have the necessary gravitational impact, it would require an implausibly large number of objects, far more than have been observed. As planetary scientist Professor Renu Malhotra notes, the amount of mass required to reproduce these effects far exceeds what we see in the Kuiper Belt. Another theory posits the presence of an undiscovered ring of debris, a dense belt of material left over from the solar system's formation. This ring could subtly alter the orbits of trans-Neptunian objects. While intriguing, this explanation struggles with key observations. For one, the gravitational effects of a debris ring would be distributed uniformly, failing to account for the distinct clustering of orbits observed in the Kuiper Belt. Astronomer Alessandro Morbidelli comments that a ring might create some deviations, but not the specific patterns we see. Those are best explained by a planet. Perhaps the most exotic explanation is the idea that Planet 9 isn't a planet at all, but a primordial black hole, a relic from the early universe. This black hole, with the mass of several Earths, would be so small that it's practically invisible, emitting no light of its own. While this theory captures the imagination, it also faces significant challenges. A black hole would generate observable effects, such as gravitational lensing, that haven't been detected. As astrophysicist Ethan Siegel remarked, extraordinary claims demand extraordinary evidence. And for now, the evidence points to something much simpler: a planet. When weighing these alternatives, one conclusion stands out. The simplest explanation is often the most likely. The gravitational anomalies in the Kuiper Belt align far too well with the predictions of a massive planet. As Konstantin Batygin remarked, Planet 9 ties everything together. It's not just a hypothesis, it's the best fitting piece of the puzzle. The search for Planet 9 is a monumental task, requiring the most advanced tools and the sharpest minds in astronomy. Observatories around the world have joined the hunt, scanning the skies for the faintest traces of this elusive world. Detecting Planet 9 demands a combination of state-of-the-art technology and sheer persistence. Telescopes like the Subaru telescope in Hawaii play a critical role. With its wide-field hypersupereme cam, Subaru can image vast sections of the night sky, searching for any faint, slow-moving objects that might betray Planet 9's presence. The Vera C. Rubin Observatory, set to begin operations soon, is expected to revolutionize this search. Its unparalleled ability to image the entire southern sky every few nights will allow astronomers to track subtle movements against the backdrop of billions of stars. Adding to this effort is the Outer Solar System Origin Survey, OSOS, a project designed to map trans-Neptunian objects in unprecedented detail. By cataloging these distant bodies and their orbits, OSOS provides crucial data that helps refine the models predicting Planet 9's location. As OSOS team member Samantha Lawler notes, their surveys are revealing the structure of the Kuiper Belt in ways never seen before, and every new object we find brings us closer to understanding what might be lurking beyond. But the challenges are immense. Planet 9's faint light, likely reflected from the distant sun, blends into the cosmic background. Its enormous orbit, taking thousands of years to complete, means it moves incredibly slowly, a barely perceptible drift across the sky. To find it, astronomers must analyze years of data, comparing images pixel by pixel, searching for that elusive motion. To narrow the search, astronomers rely heavily on computational models, simulating the gravitational effects of Planet 9 to predict its likely location. These models integrate data from previous observations, helping researchers focus on the most promising regions of the sky. Citizen scientists have also joined the effort. Through platforms like Zooniverse, volunteers around the world examine astronomical data, hunting for subtle, unexplained movements that might indicate Planet 9. These collaborative efforts highlight the power of community in tackling one of astronomy's greatest mysteries. The proposal of Planet 9 has sparked lively debate within the scientific community. While many astronomers are captivated by the compelling evidence, others remain skeptical, citing the need for more observational data. Despite the skepticism, the search continues with unwavering determination. For proponents like Batygin and Brown, the question isn't whether Planet 9 exists, but when we'll finally find it. With new observatories like the Vera C. Rubin Observatory coming online, astronomers believe we may have a definitive answer within the next decade, or perhaps even sooner. These cutting-edge tools will allow researchers to scan the skies with unprecedented speed and precision, bringing us closer than ever to solving this cosmic mystery. The hunt for Planet 9 is more than a search for a distant world. It is a testament to humanity's enduring curiosity, a reminder that even in the vastness of space, there is always more to discover. Whether we find it tomorrow or years from now, one thing is certain: the quest for Planet 9 will reshape our understanding of the solar system and our place within it. The discovery of Planet 9 would be far more than the addition of a new member to the solar system. It would rewrite our understanding of how this vast and complex system was formed and evolved over billions of years. For decades, planetary scientists have puzzled over the solar system's slight tilt, an angle of about 6 degrees between the Sun's equatorial plane and the orbital plane of the planets. Planet 9's distant, inclined orbit could provide the missing piece to this puzzle. Its gravitational pull, though faint, might have gradually tilted the entire solar system over billions of years. But its implications go even further. Planet 9 could also explain the existence of high-inclination Trans-Neptunian objects, bodies with orbits so tilted that they defy existing models of planetary formation. Its discovery would demand a rethinking of how planets interact and shape their environments. The question naturally pops up: how did Planet 9 end up in its distant, elongated orbit? Theories about its origins are as fascinating as the search itself. One possibility is that Planet 9 was born in the inner solar system, forming alongside Jupiter, Saturn, Uranus, and Neptune. During the solar system's tumultuous youth, gravitational interactions with the giant planets could have flung it outward, banishing it to the solar system's farthest reaches. This scenario paints Planet 9 as a victim of cosmic upheaval, a relic of a violent past. Another theory suggests a more dramatic origin: capture. In its early years, the Sun was part of a stellar nursery, a cluster of stars born from the same molecular cloud. During this time, the Sun could have captured a rogue planet, a wandering world ejected from another star system. If true, Planet 9 would not just be a member of our solar system, it would be an interstellar traveler. If we confirm Planet 9 was captured from another star, it would redefine our understanding of planetary systems, says astrophysicist Alessandro Morbidelli. It would show that planetary exchange between stars is not just possible, but perhaps common. The search for Planet 9 is a humbling reminder of how little we truly know about the universe. Even within our own solar system, where humanity has explored every planet and sent probes beyond Pluto, vast mysteries remain. Planet 9's story challenges us to confront the unknown. If a planet so massive could evade detection for centuries, what other secrets might the cosmos be hiding? As Konstantin Batygin once remarked, the existence of Planet 9 shows us that the solar system is not a finished story. It is a living, evolving system full of surprises. Whether we confirm Planet 9 tomorrow, in a decade, or never at all, its search has already reshaped how we view the cosmos. It has inspired a new generation of scientists, driven technological innovation, and reminded us that the universe is full of wonders waiting to be uncovered.